welcome everyone to this session 6A, addressing sustainability and environment in the industry. My name is Mats Wendel. I will lead this next 90 minutes that we have together. Normally, I work at a private company at Peab Asphalt in Sweden, a large contractor in the Nordic countries. I've been working in this industry for more than 30 years. Wow, time flies when you have fun. I am active in EAPA, and I have the pleasure to chair the HSE committee. I truly believe that our industry can be part of the climate mitigation solution and not be the problem. While doing our efforts to do that, we can foster a safe, sound, and better solution for all our workers, including ourselves. It is important that we focus on a future safe, reusable asphalt products while developing the solutions for tomorrow. Well, that's enough about me. The presentations in this session are pre-recorded, but all the speakers are here live to answer your questions. There will be a first block of 3 presentations and then a Q&A session directly after that. And then we will have a second block with the same procedure. As you might know from earlier sessions, you have a great possibility to interact. Please use this possibility by asking questions in the chat window. When someone has added a question, you also have an option to like that question. The more likes, the increased interest of the question, and I will do my best to keep track of this. It's not an easy task. However, this Q&A is for live questions for the speakers in this session only. If you have a question or that still remains or a new one arises, we encourage you to use the Congress networking area after this session. There's a special place for this session that you can enter. I looked at it yesterday and I've noticed that you click on more in order to see all the session network places. I'm sure you already seen this, but just in case you missed it. And I would be grateful when you raise a question in the chat box that you also address the question to the speaker you want you understand, to the speaker you want to direct the question to. And now it's time to kick off this session with the first speaker. Richard Taylor will present the topic, Paving the Way to an Improvement in Air Quality. Richard is the Global Technology Manager for Shell Bitumen. He has worked over 30 years of experience in construction materials technology. He obtained a PhD from the University of Nottingham and is a fellow of the Institute of Asphalt Technology and a member of the Institute of Environmental Management and Assessment. Having focused on much of the last decade on sustainable development for bitumen and asphalt. So please roll the first tape.
Hello everybody, my name is Richard Taylor. I'm the Global Technology Development Manager for Shell Bitumen. It's my pleasure to be here today to present our additive technology for reducing the impact of asphalt paving on local air quality. I'd like to start by acknowledging my co-author, Raghu Hanumanthgari of Shell Bitumen in India from the research lab and for his great work on the paper and the data behind it. I'm going to pause very briefly for the legal disclaimer. So I think many of us will be fully aware that air quality is a global issue, a very important issue from a quality of life perspective, particularly in cities. There are certain sources which are known to contribute significantly to air quality impairment, for example, vehicles in cities, thermal power plants, etc. Also construction activities, mainly in the form of dust, but also from stationary equipment. So if we look at roads, it's not generally considered to be a major contributor to air quality. However, in areas where air quality is already impaired, everything that can be done to not make the situation worse can be considered as playing a holistic part in improving the air quality of the cities. And so I'm going to describe today a additive technology known as bitumen fresh air that we developed in Shell over the last 2 or 3 years. And so the technology is basically added to the bitumen, and it reduces the air quality related emissions from bitumen during the storage of bitumen, paving and asphalt manufacture. And so if we look at where the sources of emissions related to air quality could be, we may get some emissions at the bitumen refinery or at the PMB plant. Similarly, at the asphalt plant during the storage stage of the bitumen. We also have emissions during the mixing and the loading of the material into the truck. And then finally, we will have emissions potential at the asphalt laying sites. Generally speaking, the emissions are more prevalent during the asphalt stage because simply you have more air within the sort of open structures of the mixture. So if you imagine the mixture in transport, there's more air within that loose mixture for the emissions to develop. And then when you come to the paver, the material is leaving the truck and it's being agitated through the paver. At the augers, there are emissions released. And then finally, under compaction, the roller is squashing out the air from the mixture. So generally speaking, we tend to see emissions more easily at the asphalt paving end. And so we started our study at our research laboratory in Bangalore with a set of 20 bitumen from all over the world, from different geographical regions. And we took a very wide range of penetration from 1020 penetration at one end right through to 16220. Plus we included 14 additional polymer modified bitumen samples. These were both laboratory prepared and plant prepared. They were also cross-linked and non-cross-linked. So what we have here is a very, very wide range of different bitumen types, different viscosities, different bitumen chemistries, of course, from different refineries. And we designed our lab experiments to simulate the end-to-end story. So we had some tests that were focused on the headspace in bitumen storage, some of them during the transportation of bitumen stage, the asphalt mixing stage. So we had asphalt mixers that were instrumented to measure the emissions during compaction, similar with a roller compactor, and then also with slabs of material during their early pavement life. And so we looked at the range of temperatures for the hot part of the cycle, so 140, 160, 180 for the storage, transportation, mixing, compaction. And then we looked at 60 degrees, which we thought was representative of a pavement on a hot summer's day for the emissions from the finished pavement. And then, of course, we looked at the traditional, did it have any impact on the specification properties and the characteristics of the bitumen and the asphalt? I'm not going to dwell on the experimental setup here. This is all detailed in the paper, but you can see the specific gases and particulates that we were looking at here. And you will spot that maybe not all of them are specifically air quality related. We also looked at H2S as a kind of a nuisance gas that we also wanted to detect during the exercise. And so you can find all the details, as I say, in the proceedings. So what did we find? Well, if I look at a sort of subset here from the thousands of tests that we had, this is the 20 penetration grade bitumens across the range of temperatures, and the same with the PMBs. We found pretty large reductions actually in the gaseous species. And so if we look at the penetration grade reductions for SO2 and NO, we're seeing, certainly more than 50% the SO2 at 90, and then in the PMBs we're seeing similar kind of reductions here in terms of the mean reduction of 40% SO2. H2S, rather unsurprisingly, in a PMB there's simply a little bit more of it there, but it does show that that the additive itself is also picking up some of the H2S from the PMB, certainly more than in the pen grade. And so, having satisfied ourselves in the lab with a relatively large study, we took this then out to the field. Now in the field, it's a little bit more tricky, as I'll explain later. We have more co-exposure risk. We have vehicle movements, we have wind speed to contend with, we have other sources of dust. In one of the trials, we had we were close to an airport, so we had other issues there with simply things that were just floating on the air. And so, but nevertheless, we've done now several fully instrumented field trials. I'm going to share the data in a later slide. We followed recognized methodology, and we called in an external agency, an external consultant, who were able to provide us not just with the expertise for the experimental setup in the field, but also for the equipment which was certified and calibrated, which we used in all of the trials around the world. So when we were trying to validate the findings from the laboratory in the field, we thought it was very, very important to take out as many variables as we could. And one of the key variables was simply the equipment and the instrumentation that we were using to make the measurements. And so from the field, a very, very encouraging set of data here from the real life emissions. As you can see, we had similar, fairly high levels of reduction from certain species. So if we take a look at the NO and NO2, yeah, mainly in that sort of 50 to 75% reduction there. We had some very high reductions in SO2 in some sites. You'll also see there are one or two areas where we had some co-exposure, or we believe we had co-exposure. We had some below detectable limits. We had some anomalous data I referred to there from the field trial, which was close to an airport. But in general, if we look at this data as a sort of a data set, it's pretty clear that the additive is having a positive impact on the gas and the particulate emissions coming from the bitumen during the production of asphalt paving and the bitumen storage. And so if we look at the conclusion from the field trials, yes, there were issues with the measurements at times, which is to be expected. But in general, we feel that the outcome of the field trials was pretty well correlated with what we saw in the laboratory. We would also observe during the field trials that the emissions, they very quickly disperse into the atmosphere. And so if we tried to make measurements, we try to make measurements very, very quickly when the material is fresh, when it's just being delivered to the paver. If you hang around with this and you try and make measurements later, maybe from a stationary device, you're not going to pick up a lot of emissions. And of course, I've said it already, but you really have to take real considerable care with the external parameters, upwind measurements, downwind measurements, etc. So in conclusion, both the laboratory experiments and the field measurements show that the shell bitumen fresh air additive results in significant reductions in air quality related gases, as well as other nuisance vapors such as H2S and odor causing compounds. We have the same efficacy of similar efficacy levels in a wide range of bitumen grades. We don't change the specification here. This is an additive which doesn't change the properties of the bitumen on the asphalt. And since we've developed the additive, we've now gone on to commercialize the technology and launched in more than 10 countries. And so I thank you for your attention. I look forward to any questions you might have.
Thank you, Richard, for the good presentation. Lots of information there. I want to remember you all. Some of you have found the chat, so ask questions in the chat. Moving on to the next topic. I know when this paper was written, it was quite new for many of us, and it might be still new for you. As you know, and I hope you know this, EPD, that is a used acronym for Environmental Product Declaration. Larissa Strömberg will present the paper about the experience with the Environmental Product Declarations, EPDs, and the digital solutions for the automation of the EPDs in Sweden and in Norway. Larissa has recently changed employer and now works for one of the biggest road contractors in Scandinavia, Svevia. She works as the operations manager for the company's strategical work for climate neutrality by 2045. Larissa has a PhD degree in Life Cycle Assessment of Building Materials from KTH, Royal Institute of Technology, where Larissa is now an affiliated as an industrial senior researcher. May we have the second presentation, please?
My name is Larissa Stromberg, and I will present the paper Digitalization of EPDs for Asphalt, Experience from Sweden and Input from Norway. Other co-authors are Mats Wendel, Åsa Lindgren, and Marie Byrylund. There are strong political driving forces for the climate-neutral infrastructure. The European Commission's goal is to convert the industry to be climate-neutral by 2050. The European Directive on Green Public Procurement, another one. Sweden's goal to achieve a fossil-free transport sector by 2030 and a climate-neutral nation by 2045. The Swedish Transport Administration, STA's ambitious goal of reducing the climate impact. And then we have an Environmental Product Declaration, EPD, which can be used as a proof of climate performance of building material and product. STA has begun to require that infrastructural projects be evaluated with respect to climate impact based on the total life cycle perspective as well as a price. The goal is divided into different stages. The first stage was until 2020, when the climate impact had to be decreased by 15% compared with the level of 2015, which is the reference year. Thereafter, the milestones are 30% reduction by 2025, 50% reduction by 2030, 70% reduction by 2040, and by 2045, construction of the engineering works should be climate neutral. An industry joint project was conducted in collaboration between several road contractors in Sweden as PEAB, NCC, and Skanska, Bitumen Refinery Company, NIS, and Swedish Transport Administration. The problem statement was, existing standards for developing an EPD leave some freedom, and the comparison between different EPDs, as well as between different asphalt manufacturers, becomes unreliable if different actors use different conditions for the calculations required. The number of the product-specific EPDs for asphalt concrete is still limited, both in Sweden and Norway. The development of a product-specific EPD is a comprehensive, time-consuming and costly task where external expertise is needed. Digitalization of EPD development is seen as a way forward. Our goal was to achieve a common definition of how to measure and report with EPDs, to evaluate the experience from Norway for a digital solution for development of EPDs, and to map actions needed for digitalization in Sweden. We use different methods as workshop, interviews, and literature review. As you can see on the left, the development of an EPD is based on a set of standards and regulations, from basic standards on environmental management system ISO 14001 and the standard series for life cycle analysis, ISO 14040 to 44, to more specific EPD standards, ISO 14025 and European standard EN 15804, and product-specific calculation rules, PCR. A PCR is produced by an expert group and must be approved by an EPD operator. In addition, the general program instruction, GPI, must be followed when an EPD is being developed. ISO 14025 regulates the program operator, the organization that ensures the verification and publication of EPDs in accordance with the PCR that applies to the product in question. Within the scope of this project were to compare two EPD operators' rules, GPRs, and two PCRs for asphalt, from EPD International, operator from Sweden, and from EPD Norway, EPD operator from Norway. To compare two national LCA EPD tools for asphalt and their use in the procurements in Sweden and Norway. To develop recommendations for digitalization of EPDs in Sweden. This project has identified several ways to use it in order to compare the environmental performance. develop EPDs that can be done in several ways, verify each single EPD, or EPD process certification for multiple EPDs, or pre-configuration of LCR software as an EPD tool for automated multiple EPDs. It can be done by conducting LCAs or use a general LCA EPD tool. In Sweden, we use EAPA tool, and in Norway, they use digital EPD generator. According to project interviews with EPD operators in Sweden and Norway, EPDs from different EPD operators, according to different PCRs, are comparable only for module A1 to A3, which is minimum requirement. The other life cycle stages are not assessed and thus cannot be compared at the moment. The project suggests several ways forward to use the EPDs. Easy to adapt the Norwegian EPD tool to the Swedish conditions for A1 to A3, but it must be harmonized with both PCRs for asphalt concrete and verified by both EPD operators. Variation in the Swedish client procurement requirements with EPDs is a problem and shall be diminished. In Norway, harmonization of procurements with EPDs has been done. The climate problem is a global, but the ongoing effort to develop and implement policies for using EPDs are local and at the project-specific level. What why European pavement industry has no harmonized requirements regarding calculation and should be done on the high level in Sweden or Norway on European level. The project recommendations are following. EPD standards are in place but are not fully used by Swedish clients. The significance of the current procurement requirement for the EPD according to EN 15804 can be very broad. In the examples of project requirements that this study has evaluated, the system boundaries of EPDs for asphalt are not clearly formulated. This study has identified a need to create a common terminology for working with EPDs in the Swedish asphalt industry, in the Swedish Transport Administration's procurement requirements, and the ECA tool. The EPD system is designed to estimate the environmental impact of a product. The system is not yet adapted to be used as a road project level. The EPD for the asphalt product can be securely calculated by asphalt manufacturer. The project has proposed that comparison of different environmental performances with EPDs should be initially be limited to the same asphalt mix type from different manufacturer, module A1 to 3. The use of EPDs for comparing environmental performances between alternative asphalt pavements require more detailed knowledge of service life scenarios and maintenance. The potential environmental impact of the entire life cycle of a road project is not verifiable now. The project has proposed to require an EPD depending on where it is an EPD for asphalt or asphalt mix, or an EPD for a road project, or an EPD for a road project with additions, as it shown at the picture. It is important that clients specify their requirements regarding the module A4 to D. If module A4 to D should be included in EPD, the industry needs a clear guideline for generic scenario, how to assess these modules. And we propose divide EPD used in different groups, where EPD for a road project should include additional module A4 to A5, and EPD for a road project with addition type 1 should include modules A4 to B7, and EPD for a road project with addition type 2 should include modules A4 to C4. The project team expressed gratitude to the Swedish Transport Administration and the Swedish Construction Industry Development Fund and participated company. And the project team would like to thank companies and organizations which participated in interviews. Thank you.
Okay, thank you, Larissa, for a good overview on this topic. I'm sure you have all found the chat by now, so I won't snag you with that. The next presenter is Jian Yu. He will present the paper LE to AP towards sustainable 100% surface-to-surface warm implant asphalt recycling. Dr. Jian Yu is a R&D researcher at Asphalt Nu, a newly formed joint venture in 2021 between the largest Dutch construction company BAM and Heijmans in the field of asphalt innovation and production. Dr. Yu obtained his PhD at the section of road engineering at Delft University of Technology back in 2012. His research focus on at Asphalt Nu is to develop innovative asphalt products and processes to achieve circularity, climate, and energy neutrality in 2030. After Jian's presentation, you will meet all the presenters in this first block. And now let's go ahead and play the third presentation.
Hello everyone, my name is Jian Yu from Asphalt Nu in the Netherlands. Today we would like to present you our work. It's about 100% surface-to-surface warm recycling. To begin with, the Paris Agreement and also the Dutch government gives us their ambitions about 50% circular and 100% climate neutral in the asphalt industry 2030. We would like to do it, to help to do it together. But there are different places for the limitation and challenges. The first challenge is about locally the inhomogeneity. It's so to say the black rock and the partial blending. The second challenge is about the inhomogeneity in the whole. So the high variations of the REP you applied. To tackle these two problems, we come up with our new solutions. We call it the component level recycling. That is the LEAP recycling. The LEAP the idea of LEAP came from 2013 to 2016 under the European Life project. What is component level recycling? You may think of otherwise the asphalt pavement. It is an aggregate surrounded with a mortar as glue. A mortar composed of sand and fillers and bitumen together. So with the sort of decomposition technique, so you are able to separate those two. So you're able to get your stones back and also your sand back. The aggregate, what you can get, it is with a very limited bitumen content, you can be able to use it directly as aggregate. The mortar sand contains about 10 to 12% of bitumen. You can do treatment on that, and you're able to have a new mortar sand. Afterwards, you are able to form the mortar and to make a high percentage mix at low temperature. A little bit about the decomposition process. It is more like a very big centrifuge machine. It runs to 50 to 150 tons per hour. Actually, what you do, it is about throwing the REP onto the high-speed wall. With the speed, it breaks apart, and afterwards you can sieve it out with different fractions. At this moment, we have been already applied 200,000 tons into different mixtures, and with a good experience. The aggregates, such as this is what we have said. The aggregate we have been using, and it is more from the gradations, also from the quality. It is very much comparable to the virgin stones. It is with a very limited standard deviation. And if you compare with the one with the REP, the normal REP or the sieved REP, it contains less sand and less bitumen, less filler. So the variation is very limited to be. So it allows you to use it for high percentage. The mortar, what you get, it is the orange deal. It has almost a similar gradations in the sand and fillers compared with the rest of the mortar, the virgin mortar, but it has a low bitumen content and also the lower penetration. So we have developed a blending rule to enrich it and also rejuvenate it with different by addition of softer bitumen and also rejuvenator. Afterwards, when you get a mortar, you are able to let mortar to be tested in a laboratorium scale and with the DSR. So we are able to make a high quality mortar compared with the virgin. The mortar production, that is the second scale. When you want to make it high quality and also with a high amount, in the laboratorium you need we say that is a production unit. This is the Aggregates with the mixing device. That is you can produce your mortar, and afterwards above that you will see that is a dosing unit. This is a new format of that. With the dosing unit, and then you have able to form it at low temperature. In this case, the mortar what you formed, it is about the temperature is about 110 to 120 degrees. And here you will see the expansion ratio of this formed mortar. It's about on average of 10, with their half-life of 3 to 4 minutes. It is very long, and it is a very good quality without settlement. When you have the mortar to be produced, and then you can produce the mixture, then you will see that with the 3 type of mixtures with the LEAP category, so it has a very high percentage of recycling and low production temperature. In the end, what you will see that their strengths and water sensitivity value, they has very good results. Yeah. Now we go to step further. We go for industrialization. For the handling of the recycled aggregates, it is not that difficult. You can do it with the wet drum, or you can do it with the black drum. We have been conducting research on that. It does not make much difference afterwards. Yeah, the mortar line is a different story. There is no standard mortar dosing of a mortar production unit. The only thing is you can borrow it from the mastic asphalt. We do it the first with the mastic asphalt concept. We use the steering cable from the heat asphalt, and we dose the mortar in, and also the softer bitumen. And afterwards we use a damper to lift it into the side of the plant, and by making a dosing pipe out of it, and now we're able to dose the mortar into the mixer. Of course, this is very intensive in labor, so we only can achieve for the proof concept of 20 tons per hour. We are able to make a stretch on the province of Gelderland in 338 in 2016. The second step is to make it optimized. In 2018, province Gelderland and also the province of Brabant came to us to say maybe it's time to go further to apply it for ISMAs. ISMAs has a specific challenge. It has 2 times more of the mortar than the porous asphalt, and also with a longer stretch. So what you have to do, we say we don't use the damper anymore. We are using a big cable. This cable allow you to have 50 tons of mortar to be inside, and now we lifted the whole cable, and also we built up a dosing unit in that to be able to have a correct dosing. Afterwards, we are able to produce. What's interesting to see it on the results, the standard deviation of this type of mixture, it is very limited compared with the one with a standard. The further step of what we are looking at, what now we are working on, is to go for a full industrialization. We want to have by a normal production, it to be adapted to 100 to 150 tons per hour continuous production. Means that translated to the mortar part, it is about 20 to 30 tons per hour continuous production. And with this, we are now working on it. So last list, or give a little bit idea how about the environmental benefit. We have been running a cradle to gate analysis. What you see is if you decrease we decrease our production temperature of 50 degrees, recycling of 80%. Now you get your environmental benefit around about 50%. So to conclude, it is possible to make a high quality surfaces with a very high percentage of recycling, reaching 100%, with a low production temperature about 105 to 115 degrees, and it will benefit your environmental cost for 50%. We are busy developing the mortar line, and the mortar line can be used and is already being used for different types of mixtures, and is performing well. And now we are looking for a way to make it a continuous production. In the end, we will say that LEAP, it is a method, has a good potential to be 100% surface to surface warm recycling, and to contributing the sustainable, circular, and climate neutral asphalt industry. Thank you very much for your attention. I will take any questions if you have.
Thanks, Jian. And now it's time for our speakers to join me live for this Q&A event. Excellent presentations, everyone. Thank you. So let's see. And I think everyone's here. I will simply start by asking you, Richard, a question, because we have a lot of activity in the chat room. Excuse me for just turning my head here, because I need to read the question as well. Richard, have you seen the questions?
I have, yeah. There's a lot of questions, so thanks to the audience for that.
Yes. So let's start with the top one. What are the affecting mechanisms for the emission inhibitor? Physical or chemical?
I guess so. Well, like all technical answers to questions like that, it's a little bit of both, and we believe. And so primarily the additive works by immobilizing the gaseous species by making them larger, heavier, so they can't escape to air. But then that doesn't really explain the particulate differences. And so what we believe is that the particulates are a result of the gaseous emissions. So the gases that escaped act as a kind of a seed for the particulates. The aerosols form around the gases. And so we believe there's a combination of effects there, but primarily the first effect is that the additive reacts with the species in the bitumen and makes them heavier so that they can't be released, that they can't escape.
Okay, thanks. So that was a good explanation also, I think. So let's take the second question also for you. There's a question for the test method of emission measurement at construction site. How to differentiate or isolate the emission as H2S or NO or NOx from asphalt mixture and emissions from the construction equipment?
Yeah, that's a good question, and the short answer is that you can't directly. So you measure, the gaseous species and particulates from everywhere around the site. I guess the saving grace is that with the control section, you also have the same construction equipment and you have the same co-exposure risk, broadly speaking. I mean, things can be different, like the wind can change, but generally speaking, if you're making side-by-side comparison with the control section, then you do have that interference, if you want to call it that, on both tests. So you can't isolate them from a species point of view, but if you have a control section, you would expect them both to be there.
Yeah. Okay. Very good. Thank you, Richard. I might come back to you because there's plenty of questions for you, but let's address a question to Larissa now. Larissa, when you have an EPD for a product, how do you use the information to select products that might have a higher environmental impact than another product, but provide a better service life?
Yeah, it's. I love this question actually, because right now we are so concentrated to estimate environmental impact from materials only for production of materials, for asphalt concrete, for example. But for now, we don't evaluate the other modules as module B and C and D. In these modules, you have these scenarios with different life cycle estimations. Unfortunately, we still have a lot to do to integrate it in the assessment. Why this project, which we describe in our article, we recommend to use this current system where you compare just production of asphalt concrete only for the same type of asphalt concrete, the same mixtures.
Yeah, if I may, I can just add to that question. It's an intriguing question, but really it's the road owner or the buyer of the product also that often by specification dictates what type of product you're going to use. So it's really tricky for the contractors to come up with like a general number because you don't know where it's going to be used. So is that fair to say, Larissa?
Yes, I agree. And it's the reason why we don't use these additional modules so far, because it's not so easy to estimate. It's and I agree with Matt that our clients, they used to give us functional requirement as a functional lifetime for asphalt, 10 years or 15 years. So in this, we can say somehow we estimate service life, but it's not in the same order as in a standards.
Yeah, we also have time to ask the question: where do warm mix additives and liquid anti-strip materials reside in the EPD regime that you've outlined? Have you evaluated various additives in this category? Maybe a very specific question, but
the current system with EPDs to estimate on the product level has limited by which kind of model is used to assess the environmental impact. And actually, if you compare the same type of asphalt concrete, but you use different additives, different manufacturers, they use different additives in the same type of asphalt concrete, then you can compare what will be the difference with different additives, for example. But again, if you use something innovative product, which very not similar at all what we used to have, it's difficult to compare. We need to go over to more functional requirement for the whole road structure to be able to estimate this different kind of innovative materials, which a lot of researchers presented here at the conference.
Thank you, Larissa. And let me just address two questions to you also, Jian. Since you were the last speaker, you're going to be the last one out. And there's several questions coming in here. One of them was the technology, is it valid both for paving grade and PMB binders?
No, I can explain it this way. And in the Netherlands, that is the grayscale of the use of porous asphalt is more like to be used with pen bitumen. So the test trials that we have carried out, everything was pen bitumen. It is a very hard aged asphalt with above 10 years of lifetimes. But yes, of course, that we have also did some other trials on the polymer modified variants from our neighbors also, not only here in the Netherlands. And what we have seen that is in one side is very interesting, because the polymer modified, it's if you look at the numbers, it is in the same tendency, but it's a little bit on the higher side. So to say, compare with the pen bitumen. On the other side, it brings also interesting potential, because when you separate it, so all the polymers, all the SPS are going to the sand particle, and they bring you and the extra benefit when you're trying to reheat it indirectly. So you have less emissions in that.
Okay, thanks. Let's have just a quick question here also, because there's a question about, is the porous asphalt clean before milling? Otherwise, the clogging of porous asphalt be part of the mortar, the microphone, or is it no problem?
Now, that's a great question. Yeah, thanks for asking, Jan. The question is clear. Actually, the answer is at this moment, unfortunately, no. So we're not cleaning that. We haven't cleaned it. But the fortunate part is the clogging from the Dutch highways. They are more clogging of sands, so you can still use it. Yeah, of course, we have to, for large scale production, you have to look at the other particles and also the other pollutions inside to have a limitation.
Okay, thank you. Very good, Jian. Unfortunately, time flies. We won't have time for more questions, but if your question is unanswered, I want to recommend you to copy it and use it in the Congress networking area under this session's headline. And I want to thank you all for being with me for this Q&A. So thanks. And I'll move on now to...
Thank you very much.
Thank you. Thank you. And I'll move on. It's time to start the second block of 3 speakers. Marcela Baliche will present the paper Recycled Plastics from Different Sources for Asphalt Pavement. Marcela is the Specialties Technical Manager at YPF, the largest integrated O&G company in Argentina. As she is in charge of managing the portfolio of binders, as well as the innovation at YPF's Customers Technical Assistance in this area, Marcela is firmly convinced that a lot can be done to maximize the reuse and recycle of raw materials, enhancing the asphalt properties. So go ahead, Marcela.
My name is Marcela Baliche. This study showed the result obtained in the lab and then in the field of asphalt that incorporated recycled plastics. It has been developed considering the imminent need to change from the current linear economic model to a circular one, as in the latter prevails the material utilization, recycling, and uses reduction. This project propose an alternative for the sustainable management of polyethylene packaging waste coming from the agricultural activities, the lubricant and other automotive fluid plastic packaging waste, which may be incorporated into bitumen for road construction. The 4 entities participate in this project were the technical service of YPF, an Argentina oil company, with the engineers Rubén González, Mike Vargas, and I as the team leader. The doctors Silvia Angelone, Fernando Martinez, and Magister Karina Casó from the Institute of Applied Mechanics and Instructor of the National University of Rosario in Argentina, and the ACA, that is the Argentine Cooperatives Association, which supplied the recycled plastic for this project. And finally, the road construction company named Unidad Ejecutora Corredor Vial number 4 of route number 18. The goal of this study was to test in the field the behavior of new asphalt layers that incorporated recycled plastics. In this way, the ecological impact of plastic waste would be reduced, providing performance benefit to the road. To achieve this, an action plan was developed by the project team, which involved first, the evaluation of different possible recycled plastic sources, focusing on 2 polymer types, polypropylene and polyethylene. Second, valorize the plastic waste as an asphalt raw materials. Third, assess the mechanical and rheological improvement conferred to the asphalt layers by deposited impact to their extended durability and improved water resistance, leading to less failures. Fourth, with the experience obtained, create protocol for the use of such new mixture, and finally, promote regulation to the Argentine National Highway Administration. Two homogeneous recycled plastic type in granulate form were first analyzed and then used. One of these recycled plastic was composed of opaque green plastic lentils coded PB in this study, and the other was made of black plastic lentils coded PM. Each lentils had a mean diameter of 5 millimeters with a mean weight of 30 milligrams with an important hardness. The PB material was obtained from the recycled used drum that had contained agrochemicals. This drum had been triple washed and punctured for their conditioning, as stated by the Argentine standard for the safe, responsible handling of such waste materials. The green plastic analysis made with the scanning calorimeter showed that it was composed mainly of high-density polyethylene. The black plastic lentils coded PN in this study were obtained from the recycling of silo bags. The silo bags are usually used in Argentina to provide low-cost temporary hermetic storage for grains. The black plastic analyzed by scanning calorimetry determined that they were composed mainly of low-density polyethylene. In previous lab study conducted before the field test, a softer CA20 bitumen was used to incorporate the recycled plastic both in pellets and in powder, in 4 increasing amount from 1 to 4%. The samples were compared with 2 other bitumen control samples, which were a conventional CA30 bitumen and a commercially available polymer modified bitumen named AM3. This bitumen met the respective Argentinian specification. The physical and rheological characteristics of these 3 bitumen are shown in this slide. The previous test showed a level of 4% of PE when added to the CA30 bitumen did not always result in homogeneous distribution of the PE material. It was also found that adequate mixing temperature, speed, and time are key variables in the mixing step to get homogeneous final product. It was concluded then that the CA20 bitumen was the best option to incorporate the recycled plastic in order to get a compatible plastic bitumen mix. Going to the field work between late 2018 and January 2019, 5 different types of experimental pavement sections were constructed on the provincial route number 18 of the Argentine province of Santa Fe, from kilometer 11 to kilometer 11.5. The scheme of the lanes going to and coming out Rosario City is shown at the bottom right portion of this slide. There, you might see that 4 of the 5 pavement sections shown in the upper part of this scheme of 100 meters each were built using modified bitumen with either recycled green plastic coded PB or black plastic coded PM. The process used to incorporate the mentioned recycled plastic are identified in the graph either as BS when the dry process was used or BH when the wet process was used. You will also see that the 5th asphaltic section of the descending line at the extreme right of this graph used a conventional CA30 bitumen. This section was selected as the reference pavement of this experimental work. Finally, at the bottom part of the graph, you will find the ascending lanes going out of Rosario was built using recycled black plastic incorporating with the wet process, coded as the CA20-PNBH. In summary, this was the first asphalt pavement construction in Argentina, which used recycled plastic from drums and silo bags. The following conclusions were obtained. Firstly, the lab result of the asphalt obtained from the experimental paved section were in good agreement with the product previously made and analyzed in the lab. However, the voids measured in sample extracted from the experimental sections showed a higher value when compared to the lab mix one. Secondly, an improved resistance to moisture damage was detected in all asphalt that incorporated recycled plastic as measured by the tensile strand ratio when compared to the CA asphalt adopted as reference. All paved sections complied with the permanent deformation specified by the Argentinian road authorities. Fourthly, while recracking problems had been observed a year ago in the US, in pavement that included modified bitumen with recycled PE wash. Our periodic assessment of our experimental section, which concludes macrotexture analysis by the sand patch method, rad depth assessment, as well as sample extraction, so far have given positive results, especially on the CA20 PNBH asphalt mix using in section 2. To conclude this presentation, I would like to mention that further construction using this recycled plastic are being conducted along this year in Argentina. Thank you.
Thanks, Marcela. Interesting presentation. The next speaker is Davide Lopresti, and he will present the paper, What do national road authorities know about and do about sustainability assessment of road pavements and asphalt mixtures? Now, Davide is an academic in Italy and in the UK. His area of research is sustainable and smart development of transport infrastructure. And he believes that we should engineer sustainable development in any sector by embracing innovation and new technologies to support health, society, and respecting the environment. Let us see Davide's presentation.
Thanks, Mr. Chairman, and hello, everyone. I'm Davide Lopresti, the coordinator of Pavement LCM, and I am an assistant professor at the University of Palermo in Italy and a visiting academic at the University of Nottingham. I'm here on behalf of my co-authors, which are making big efforts to carry out this project, which is allowing us to, first of all, understand what European National Road Authority know about sustainability assessment and allow us to work to provide them with a framework to actually carry out sustainability assessment according to standards. But what is sustainability? Well, first of all, it's years that we are working to introduce sustainability in pavement engineers, and we believe that this is needed at the technology development stage, where technology development with practices such as maximized recycling should be supported by an exercise that allows to assess how sustainable are the choices. But this will need to happen also whenever we manage an asset like the road, and whenever we want to understand whether this maintenance and rehabilitation strategies is more sustainable than the other. In other words, we would like to include a sustainability performance-based management of road pavement, which is what we call life cycle management. Hence, Pavement LCM is a project that is supported since the 2019 by the Conference of the European Road Director to exactly provide this type of knowledge and tools to CEDR. The goals of the project are and one of introducing guidelines on how to perform lifecycle management with a specific focus on sustainability assessment, but also to create a platform for the interactive transfer of knowledge. So we learn by doing and sharing, and to produce finally a package of framework, data sets, and in the end, the tools to allow road authorities to implement this concept within their organization. So let's see, first of all, what do they know, at least up to 2019, where we had the chance to collect the interviews. So to understand that, we perform some interviews by sharing a questionnaire amongst different road authorities in Europe and also in California. And what we find out is that there are clear differences and clear different level of application of what we think are important concepts related to sustainability and sustainability assessment. Different definition for a greener asphalt, for instance, or a greener pavements. Certainly durability is considered one of the most important aspects, but there are differences also in other sectors, such as what is intended for sustainability assessment, and the majority of people consider environmental and economic as the main pillar. So the social pillar is still blurry for the majority. Organizations are aware of the standard sustainability assessment, and they know that within the organization, someone is performing it or using to procure projects. And there is usually or a department dedicated to it or an external consultant that carry out the job. The exercise is made mainly at the planning stage, and there is a balance for the actual reason they do it, but mostly is for decision making. And the exercise for road authorities, it's mainly important for the maintenance stage, of course, because they have to manage the asset. And exercise carried so far are more focused on project level. So these are some of the results that we wanted to share, just to have an idea and to have also to understand where we should lead to improve what they know. And within this exercise, we also found out some best practices that we are sharing here in the slide, and will be in the deliverables soon. At the end of the project, we'll share all the deliverables, and it's also on the paper. So for the sake of time, I'm going to move directly on what do national authorities do about it. So what are they doing? And first of all, I will say they are supporting Pavement LCN, which is a project that is supposed to provide them with this type of knowledge. And the state of the art was done with the interview, and the results are on the paper. But we're also organizing webinars. We organized two, one in 2020, one in 2019. And the second one was very successful with the support of EAPA this December. But we're also creating documents like technical briefs that can be distributed among the staffs of National Road Authority. And what else they're doing is that they would like to have a framework to actually understand how to comply with standard procedures. Well, this is exactly what we're doing. And for those who don't know, since 2011, at least at the European level, there is a committee, which is the SEN Technical Committee 350, which is working on defining a standard for sustainability of construction work for civil engineering works. Well, within these standards, it is suggested to perform an exercise that considers indicators that cover the environmental, social, and economic pillar, certainly, but also to identify what is called technical and functionality requirements. The exercise is intended to help for decision-making related to a project, and to do a sustainability assessment with quantitative assessment of the value of the indicator by using life cycle techniques such as LCA and life cycle costing, doing this exercise for all the stages of the work, for products, processes, and services, and is applicable to new as well as existing civil engineering works, and using environmental product declaration as a communication tool. So in order to do that, we set up a process which is defined here in the slide, all the stages are covered in the deliverable, but today I really wanted to give you a highlight of two parts which are very important. First of all, within the objective assessment, it's what we think are the system boundaries of the exercise. Well, we suggested to use the framework now specifically for pavement, and in particular by doing two exercises which are different in nature for us. One is for pavement materials, the other one is for pavement maintenance activities. Painting, signals, lighting, barriers for the moment can be out of scope, even though the framework is flexible enough to do that. And the two exercises are really, as you see in the slide. So first of all, we have a cradle to gate exercise where we can include the production of asphalt mixture, for instance. And this is a different exercise because this has experts such as material scientists, material supplier, asphalt manufacturer, contractor, and the indicators are also specific for this phase. While the other exercise, which can be cradle to laid or cradle to gray, well, this is for evaluating the sustainability of maintenance rehabilitation strategies, for instance. So this is what should be duty of road owners and road managers. So concept like reference service life are introduced, and functional unit is here for square meter of pavement. So different exercises that are linked by one product, which is the EPDs, that should be developed at the pavement materials or product side as an output, and should be used as an input when we evaluate, for instance, certain maintenance strategies. So this is one of the main message. And the other one is that we developed a list of indicators that cover the three pillars as well as the technical and functionality requirement. And these are based on a survey we did over standards and different projects, as well as contacting road authorities. These indicators are divided by pavement materials, pavement activities, and can be all quantified mainly with life cycle techniques. So as a concluding remarks, sustainability assessment is certainly standardized practice now, and each sector should tailor this procedure to comply with this standard. Pavement LCM is doing exactly that by providing knowledge, tools, and framework for performing sustainability assessment. And this exercise should be divided in sustainability assessment of pavement materials, sustainability assessment of pavement maintenance activities, and this should be done in synergy among the stakeholders. So this synergy is very important, and that's why we would like to introduce what we started at the end of 2020, where we did the first workshop sustainability assessment together with EAPA and CEDR and EAPA, organized it together, and we facilitated by providing result of panel LCM. We suggested to stay tuned because next there will be the next one very soon. So thanks for the attention. Please don't hesitate to contact us for any details, and have a good day. Bye.
Thanks, Davide. Very good presentation, and I want just to emphasize on that you can actually go and see this webinar in already now if you want to. Well, not now, but it's also possible to find it under the EAPA.org website. You go on their events and then click webinars. And it's a lot of good information there. The next speaker is Javier Navarro Dominguez, and he will present the paper Physiochemical Interactions of Reactive Surfactants with Bitumen. His research activity is mainly focused on the design of micro and nanostructured bitumen products based on the analysis of the formulation and processing condition with special emphasis on recycled polymers, crumb tire rubber, greenhouse plastics, and additives to reduce the working temperature. Let's listen to Javier.
Okay, this presentation is about the physicochemical interaction of a reactive surfactant with bitumen. In general, it's well known that egging is the main factor that contributes to the deterioration of asphaltic pavements, leading to the hardening of bitumen and the embrittlement of the pavement. Bitumen egging takes place in two stages at different rates. The most intense one, called shorter egging, takes place at high temperatures during processing operations such as mixing, storage, transportation, laydown, and compaction. Secondly, the so-called long-term egging happens slowly during years at ambient temperature and results from the environmental condition while in service. In general, egging is a very complex process which involves different mechanisms such as oxidation, volatilization, exudation, etc. However, the main one involved is the oxidative egging that causes a strong modification in the chemical composition of bitumen. During oxidation, new carbonyl groups are formed and the polarity of the molecules result increase. Thus, whereas saturates remain relatively unaffected, aromatics are transformed into resins and resins into asphaltenes. Therefore, bitumen oxidative egging favors electrostatic interaction by hydrogen bonding of the molecule, a fact that contributes to the agglomeration of the asphaltene structure and leads to the embrittlement of the pavement. From a rheological point of view, for example, if we focus on the Loss modulus curve versus temperature, egging causes a shifting to the curve to the right, leading to larger values at every temperature and a clear increase in the mechanical ground transition temperature. The modification of this thermodynamical response causes the hardening that leads to cracking problems in the resulting pavement. In order to alleviate this problem, rejuvenators are usually being improved. According to this, even though bitumen rejuvenation ideally should revert the effects of oxidation and volatility losses, in fact, what they really do is to restore the original rheological properties of the binder, so that most of them are softening agents that reduce the stiffness of the egg bitumen. Here, a new concept of physicochemical rejuvenation is presented that involves the use of amphiphilic surfactants formed by a long aliphatic apolar hydrocarbon tail with a polar reactive head able to chemically interact with polar bitumen compounds. Therefore, it is expected that by attaching reactive molecule to asphaltenes, the surface polarity is reduced and then their association into larger structures is inhibited, leading to a disruptive effect. Two different sets of surfactants have been used here, both of them having an aliphatic tail of 12 atoms of carbon, dodecynyl succinate anhydride, called DSA, adodecyl benzene sulfonic acid, DBSA, and its sodium salt, sodium dodecyl benzene sulfonate. In addition, in order to study the effect of the polar reactive head, succinate anhydride and benzene sulfonic acid have also been used as bitumen modifier. And finally, a typical SBS from dinosaur commonly used to modify bitumen has been used for the sake of comparison. In general, a hard 1322 bitumen has employed as a base material for this study and modified with 3% of every reactive surfactant. After modification, samples were submitted to a rheological characterization, infrared spectroscopy, thin layer chromatography, atomic force microscopy, technological tests, etc. First of all, a preliminary study based on conventional tests has been carried out in order to analyze the potential modification of the selective additives. As presented here, this table shows us how the hardening of neat bitumen is produced after the processing of the sample. This table also illustrates that reactive surfactants exert a quite different modification of the technological properties. Then the addition of alkyl benzene sulfonic acid, DBSA, leads to a decrease of 3 decimal millimeters in the penetration and a clear rise of 4 degrees in the softening temperature. By contrast, the alkenyl succinate anhydride, DSA produces an opposite effect, revealed by the subtle penetration increase and a clear drop of 4 degrees in ring and ball softening point. Consequently, DBSAs appear to us as a soft stiffening agent, whereas DSA seems to produce a softening of the binder after modification. The effect of both additives at high in-service temperature may be analyzed by means of draw curves at 60 degrees. When analysis unmodified binder, it is clear that blank sample only undergoes a slight increase in viscosity due to bitumen oxidation during processing. However, DBSA modified bitumen presents a remarkable increase in the Newtonian viscosity, reaching values very close to those of SBS modified binder. On the contrary, DSA modified bitumen undergoes a completely different effect and clearly presents a notable drop in viscosity values. In order to characterize the thermohydrological behavior in a wider temperature range, temperature sweep in oscillatory shear at 10 radians per second has also been performed on gum samples. In this sense, this figure shows the rating parameter with temperature. In general, this figure points out that the previously commented effects appears again, but now from 13 to 113 degrees. Consequently, DBSA yields a remarkable increase in the rating parameter, whereas DSA, the succinic anhydride surfactant, shifts this function to lower values in the whole experimental interval. Finally, in the bottom right corner, it is important to note that at minus 30 degrees, DSA also gives rise to a lower values of the complex modulus, pointing out a significant improvement in the low temperature properties, where thermal cracking usually happens. Therefore, it is clear that sulfonic acid-based surfactants work as a typical modified agent, whereas DSA may be employed as a softening or rejuvenating agent. In order to analyze the chemical origin of this modification, infrared spectroscopy has been performed on succinic anhydride surfactant samples. As shown in this picture, the typical bands associated to anhydride carbonyl groups are reduced during processing, and additionally, the appearance of new peaks associated to the formation of ester groups are clearly observed. Consequently, as shown in the bottom picture, the DSA molecule result attached to polar bitumen compounds by means of covalent links. In addition, in the case of sulfonic acid surfactant, the chemical modification pathway is really different. Thus, it is well known that sulfonic acids are able to protonate the pseudoatoms of asphaltenes, leading to the attachment. Consequently, in this case, chemical evidence of what is happening here is the increase in the SARA chemical composition of the asphaltene fraction beyond the 3% of the other surfactant. In addition, when the insoluble fraction in NF10 is submitted to thermogravimetric analysis, the derivative of weight cloth curves clearly shows the appearance of a new peak, which is associated to the development of the ionic pairs between asphaltenes and DBSA. Consequently, it has been proven that both additives are linked or may be linked to polar bitumen compounds. However, despite they present a similar hydrocarbon aliphatic tail, they produce an opposite modification. Evidently, this outcome should be related to the directed head of the surfactants and to the type of physicochemical interaction with bitumen molecules. In order to shed some light on this issue, these molecules are being also modified with DBSA and the sodium salt DBSS, and with the same molar amount of the polar head of both surfactants. It is clear from the figure on the left that the sodium salt hardly modify the rheological response, whereas benzene sulfonic acid brings about a huge increase in viscosity. Therefore, the reported formation of ionic pair has a strong structuring capacity. On the other hand, according to the picture in on the right, the individual addition of succinic anhydride only leads to a minor increase in viscosity. Therefore, taking into account that in this case, the modification is caused by the formation of covalent links having a much lower polarity, deformed structures are completely unable to promote the asphalting aggregation. However, if we compare the modification caused by the polar head on both additives with those caused by the surfactant, it is clear that the presence of the aliphatic tail leads to a remarkable reduction in the viscosity. Therefore, this result confirms the previous assumption, and the attachment on the non-polar aliphatic change clearly present a disruptive effect. Finally, by the atomic force observation, these effects can be corroborated. In the case of subthin anhydride, the disruptive effect of the aliphatic tail is dominant because the 4,9 link hardly contributes to the asphalting aggregation. And by contrast, the benzene sulfonic acids, the disruptive effect of the aliphatic chain is clearly exceeded by the structuring effect of the polar head. Then the ionic pair formed by S-basic interaction favor the association of asphaltenes into larger structure, leading to the formation of new structure, enhancing the rheological behavior. Thank you very much for your attention.
Thank you, Javier. Interesting presentation. Let's see if I have Davide as well. Javier, you can have your camera on, and Marcela as well. Okay, very good. Marcela, can you turn on your microphone? Excellent, because I'll start with a question for you. There's a lot of activities in the chat. How do plastics affect the recyclability of the mixture? And when heated in the parallel drum, if you do recycle this, will it lead to extra emissions, do you think?
Yes, we are studying this point at this moment about the effect of the plastic in the recyclability of the mixture, but we expect, consider the information that we have about this topic, that the impact of the plastic will be the same as the rest of the polymer. We know effect of the different PE, polyethylene, high and low density in the asphalt mixtures, that the effect in the durability of the bitumen of the mixture can be not affect negative. We expect that the results are right, good, and in the next step we test with the recycled material. In this case, the only difference it can be in the use of the recycled material, not virgin, but the result that we expect are.
And let me address the next question to Davide. Although you have been active in the chat answering questions also, very good. But it could be good to also to ask this question about, are there enough students interested in this topic who can help plug the skills gap at road authorities? You think that?
Mats, thanks for the question, and good afternoon, everyone. It's a very good question, and I'll say we, I'm talking about academia, is certainly starting introducing sustainability as a concept and sustainability assessment as a tool, as a practice within our courses, because this applies really to any sector. But I will say that this is not enough to actually make the change, because this is a cultural change. So we're very happy that we can work with road authority, the asphalt industry, having a top-down approach, not only the bottom-up approach, because this is a journey that we really do together. When you have to build new skill sets, we do need to do it together. And hopefully also the platform that we are now bringing on with EAPA, hopefully we'll have this goal. And in a few years, it's going to be something a little bit more standard, normal, to talk about sustainability assessment.
Yes, but it also attracts, I think, the youth of today is very much indeed in focus in this area. So maybe that's a positive way for our industry to.
It does. It does.
Yeah. Very good. Thanks, Davide. For the sake of time, I'll move over to you, Javier. We got a few questions for you as well. And the top one right now is don't you think these reactive surfactants will go at the bitumen aggregate interfaces during the hot mix asphalt manufacturing instead of interacting with asphaltenes? These polar molecules have strong affinity for mineral surfaces.
Yes, that's right. In fact, even though I didn't have time to present all the results in one of the slides, I show some data about excessive drop measurement. That means to analyze the dynamic contact angle over a typical mineral surface of a local mineral surface. What we have found is all these additives, as these people mentioned, have a strong affinity to the mineral surfaces. So they also contribute to reduce the contact angle. And additionally, we also have performed some results about the compactability. So we have obtained better results in modified bitumen sample than in regular sample. Even though we have used, for example, in contact angle measurements, relatively low temperature of 110 degrees. At this low temperature, these additives were able to reduce the contact angle by 20-30 degrees. Okay.
Okay. Thank you. Let's have another question as well, and that is that as DSA is an unsaturated molecule, one double bond, it is a potential reaction partner for oxidation. Have you tested the behavior of DSA modified bitumen in oxidative aging?
Yes, we have done this in this test. We have done both of egging methods, rolling thin film oven test, pressure egging vessel. These results are to be published in the next few months. What we have found is not only an oxidation effect, but also a volatilization effect. There is a problem with this molecule is submitted to temperature higher than 180. But even with the oxidation in volatility losses, we have found that these molecules remains after a modification process of 1 hour, 2 hours. So even though these samples have been also oxidized, but the molecule remains after this process, even though maybe 30% of the molecule have been lost.
Okay, thank you. Unfortunately, Marcela lost her connection to us, so she won't join us right now. And it's time for us to close this session. So I want to thank you for the Q&A, Davide, Javier, and also thanks, Marcela, if you look at this afterwards. And by that, I want also to thank all the presenters in this seminar or in this session for the efforts, and also you as the audience. Fantastic activity here. A lot of questions in the chat, and if you want to listen to this session again, the recording will be available in a few days, maybe sooner than so. So do not forget to visit the networking area to interact with colleagues. I think you gotta go in the lobby to that networking area in order to find it. And I hope to see you in future events. Take care and have a great summer. Bye.
Bye. Thank you, Mats.